Hello, everybody. Okay, I'll be just closer to the microphone for a bit. Hello, everybody. We have the pleasure this morning to have here with us Professor Iryna Gurevych from the Department of Computer Science at the Technical University of Darmstadt in Germany. She's also the director of the Ubiquitous Knowledge Processing Lab. She has extensive knowledge in the field of natural language processing, semantic text processing, machine learning, and so on. She has numerous publications and numerous awards, which attest for her contributions to the field that we are here to hear about. And she's also she's also the vice president-elect of the Association of Computational Linguistics, and we will have the pleasure today to hear about her work on combating misinformation with more realistic natural language processing.
Yeah, thank you very much. Good morning, everybody. I hope everybody has had a great night. So just to get you awake, I have made a mistake in my title. So I will not tell you the reason of this, but if you listen carefully to my talk, by the end of the talk, you should know. So for sure, in the recent years, many of us had these kinds of conversations. The vaccines aren't safe. My uncle died after getting the shot. So not probably had, but listened to such conversations. The other one replies, what study X proves they are safe? That's the truth. Okay, well, it's not my truth. So I have two disclaimers about the talk. So first, my talk is not about finding the truth. So that's the obligatory question I used to get in the past without this disclaimer. I am not a philosopher and I do not claim to know the truth. We may not even know the truth ultimately. So the truth may just not exist. So this talk is about how to detect, how to verify or debunk, and how to communicate about real world misinformation. The second disclaimer I have, I'm not going to present you one-size-fits-all solutions. So you can view this talk more as a debate where we analyze the current state of the art in NLP regarding this particular problem domain and suggest some future research directions and invite you as computational linguistics researchers to join this very exciting field. So first of all, let's look at one real-life example taken from Twitter. So the tweet is that somebody always knew that a substance called chloroquine, abbreviated as HCQ, worked for COVID-19. And then you have a reference, which is an authentic reference of a scientific article attached to this claim. And of course, we can see in this example that the tweet spreads misinformation about coronavirus because it's a false cure. So if you start reading the article, and I on purpose have chosen a very simple example where you can see this just by the title. The scientific article does not actually talk about COVID-19, it talks about a different disease, which is SARS. However, the misinformation has this nature that people do not check carefully what they are reading or what they consume. And they may just think, because it looks quite credible on the surface, you know, somebody makes a claim and attaches a scientific article. This has a lot of credibility, so some people might be misled, and well, then you have potentially very, very bad consequences. People can die or be hospitalized because they took the wrong substance. So in real life, such examples can be much more complicated because you cannot recognize that this is a false evidence by the title. So the title may look quite neutral. You only need to read the article in order to understand that it actually is not supporting the claim, which most people would not do. And this is where we require some support to highlight such cases of misinformation. So now machine learning and NLP are nowadays quite powerful for fighting misinformation if and only if we make certain assumptions about the scenario and we have certain resources. So for example, if we know what fake news look like, and if we have data sets to teach our models for the given topics, then we can evaluate the information. However, the learning process is very expensive and false information appears all the time. So the topics change as the life goes. So one key problem in this field is the problem of domain adaptation. That is, how can we adapt to new examples of misinformation effectively and efficiently? So effectively means that the misinformation can be really recognized, and efficiently means is that we can have a very efficient models, as NLP is nowadays based on transformers, which are very expensive to train. That plays an important role because we cannot train an expensive transformer model all the time or expensively retrain it. We need very lightweight technologies, since the misinformation, once it appears, needs to be stopped in a very short frame of time. So my group approaches this problem of fighting real-world misinformation with NLP from different perspectives. So the first perspective is the detection. That is how to adapt to novel, harmful content efficiently. And also the realistic misinformation detection. You will see why realistic is so much important in this context. And the second perspective is debunking. So here we create several data sets, and we study a lot of data and try to understand the problem better and analyze the current state of the art and the current research gap. And the final perspective is the communication. This is something which is, in my opinion, almost ignored in NLP so far, but it is well known that misinformation is psychological phenomena. So it's not about having access to the right evidence and being able to read it and understand it. This has something to do with the psychology of people, how to make them accept maybe the evidence that debunks the claim, since people like to discard the evidence that does not match their own beliefs. And in this part of work, we work with cognitive psychologists to see how NLP could be used in order to help people change their point of view as a result of information debunking. So I'm going to talk about all three perspectives. And the first one is detection, which is identifying harmful content in advance. That means before it has spread all over the world. And here I have already pointed out that misinformation comes in various formats, and especially it is very dangerous on social media because it tends to spread very soon. And two main problems with the state of the art in machine learning and NLP arise from poor generalization of the current technologies to new data, and they are overfitting to the training data on the one side. So that's the effectiveness. And the second problem is the efficiency, since current NLP is based on transformers, which are very expensive to fine tune and adapt to new domains. So our goal in this part of the work is to create an approach which is more efficient and more effective. That is, it generalizes better without the expensive retraining. So consider this example where an existing model has seen the instances like the government discriminates against the unvaccinated and they'll send us to prison camps and take away our rights. So this is tagged as harmful in our training data. And the other is vaccination reduces death and hospitalization rates. And this is tagged as neutral in our training data. Now a new example is introduced that we want to classify. Refugees from Ukraine face heavy discrimination in Poland. They are basically treated like prisoners with no rights. Okay, so we want to classify this example, which is a completely different domain. And we have not seen any such examples in our training data. So the main intuition behind our approach is that instead of retraining, our system would try to help the decision process in classification by reminding the existing model of the most similar example it has seen in the existing training data. So it would kind of recognize the similarity. That's a lot like the government discriminates against the unvaccinated. They'll send us to prison camps and take away our rights. So it can detect the similarity between this new example and the other example from another domain. And this way it can make an inference that this should be classified as harmful. So the current state of the art, as I already mentioned, in the domain of fact-checking is based on transformers like BERT. And they are expensive to use, of course. And our group has created an alternative to transformers or BERT, which is called sentence transformers or SBERT. SBERT creates a semantically rich representation of text in form of dense, high-dimensional vectors using transformer-based Siamese networks optimized with cosine similarity. And these vectors can be used to train simpler learners that are much cheaper than the transformers. A major problem with those SBERT representations, which are widely used for different kinds of text classification problems in the field, is that they have a fixed representation. That is, they are not optimizable for a given task and data set. And that's where a new method that we create comes into play, which is a joint research project between our lab, Intel, and Hugging Face. So this method called SetFit optimizes our SBERT model using a paradigm from computer vision called contrastive fine-tuning. And then we can use this updated model and reap the benefits of both transformers and the cheaper learning algorithms. And in this way, SetFit makes sentence transformers a viable model for end-to-end learning. In this particular example, this is the domain of fact-checking. So in this graph, we can see how SetFit competes with one of those large language models, GPT-3, which is massive on the Raft few-shot text classification benchmark. So the results are comparable for many data sets. Sometimes they're a bit worse, sometimes they are a bit better, but the main message of this evaluation is actually not the effectiveness, it's comparable, but the efficiency, because the SetFit approach that we have proposed is much more smaller and therefore much less computationally expensive, and therefore we can much more easily adapt to new domains that arise in the field of misinformation. So we can also see that our method performs well in the few shots setting, which is also quite important because we are not likely to have a big data set for training the fact-checking models. However, when we have more training examples, it reaches a performance plateau. And just for comparison, you can see in the different graphed how the transformer, the classical transformer models behave. And they are more expensive to train, and they don't perform well when we have little training data. But as they get more training data, they are strong learners and their performance increases. So the behavior of these two approaches is quite different, which makes them suitable for different kinds of scenarios. And we claim that our approach is much better suited to the fact-checking scenario. So the next question is, we ask, can we use both set-fit and transformers together to more effectively fight the misinformation? And we combine set-fit and BERT into one system because real-world data are growing all the time, and we don't need to keep retraining expensive model. However, we can use our inexpensive pre-trained embedding models like SBERT to encode new examples in addition to a fully trained transformer model, for example, BERT. So this is the way our algorithm works. So we first optimize our embedding and classifier on a small subset of the data. We then embed new test data with the updated embedding model, set-fit1. We then do a similarity lookup and concatenate the most similar training and test examples together. And then we predict with the frozen transformer model, showing it the most similar example it has seen before in the training data. So these are our preliminary results. This is a work in progress. I'm not going to explain them in all the detail. I just want to highlight some main messages. So the set-fit approach is the third line in the table. The transformer is the second, and the first is a baseline where we perform a similarity lookup with a set-fit model. And our best model is the last line, set-fit1 plus transformer1. And we can see that the learning behavior of these models is different. So this is exactly what we have already seen. So for example, the transformer starts quite at a low level, but then as transformer has a lot of examples, the performance is much stronger. For set-fit, the best performance is with 200 examples, and the best trade-off of effectiveness and efficiency is with our current model, where we combine set-fit and transformer, and it's the second cheapest approach. Now I move to the second part of my talk, which used to be verify, but now I call it debunk, and I hope you know why after this section. So first, I'd like to show this graph. So the ultimate goal of the NLP technology is to actually support fact checkers in checking the information as it appears online. And here we evaluate claims taken from a fact-checking website called PolitiFact, and we plot the number of false, true, and mixed claims over years. So what can we see here? We can see here the empirical evidence that the number of false claims is rapidly rising in the recent years. So that's the blue line, and it goes significantly up. So what does it mean? It means that the focus of the work that the fact checkers are doing has shifted towards false claims, right? So this is where they need a lot of support because the number of false claims is deeply, and there's a lot of work involved checking that information. What does it mean for Now, it's very challenging to define real-world misinformation, and we propose this definition: real-world misinformation are non-true, harmful claims that professional fact-checkers deem important to verify. And this real-world misinformation is characterized by two properties. So one is the volume. As I said, the number of false claims is growing a lot, and the fact checkers need to prioritize their efforts. So it's impossible to check everything, so they need to prioritize the efforts. And the second property is they need to consider the relevance of the claim, because they have limited efforts, so they need somehow to focus on the claims that have the greatest potential to be harmful. So that's the heuristic they inherently use. And what it means for us as NLP researchers, we want specifically to support the debunking of this class of information that has this greatest potential to have a damage in the real world. So now let me give you 3 claims from, I think, the most popular fact-checking data set that NLP researchers are using. The first is Coldplay is French. The second is 500,000 sharks could be killed to make the COVID-19 vaccine. And the third is Beat It is not a song by Michael Jackson. So they are all taken from a data set. They are not made up. Now it's your turn. Which one is the real world misinformation from these 3? Anybody has a guess? I mean, an educated guess, of course. I will ask you to provide justification. Next. Yes. Not? Sharks. Yes. Sharks is misinformation. So why do you think so? No, I would not be so sure, actually, if you research scientific literature. But actually, I'm not asking you what is true or false. So my question is rather from these 3 examples. One is a real life one. So the focus is on real life, and 2 others are made up examples. But they all come from an NLP data set. Yes?
Refers to relevance. Because if fact checkers have a big volume of data, they need to address the type of misinformation that would have the biggest impact on users.
Yes.
So even if they all were real life misinformation, fact checkers would probably focus on the one that has the biggest impact, which is the one about the sharks.
Okay, so I love this audience because the audience answers already the next question that I have not even asked. So why is this real life? But I mean, your answer implies actually that the sharks example is a real life example. Right? Because we somehow feel, you know, it's relevant to us. So we want to know, is this true or false? And actually, I mean, it's not that kind of made up in the strict sense, because for some vaccines, some substance from sharks is really used, you know, so it could be the case that it's also used in COVID-19 vaccine. And once I've given this talk, so I had a biologist, right? So while I was talking, he was already checking the Medline articles and found a couple of articles that could lead people to believe that this claim is true. Yeah, so thanks for this lovely discussion. And yeah, so the answer is 500,000 sharks, you know, and it's real world misinformation. But why am I showing that? Because the other examples are taken from the fever data set, which is the most common data set in NLP for fact checking. And you can see they look pretty much different. Okay, so for various reasons. And one particular thing that, you know, if I had more time to continue this discussion, but unfortunately I don't, Coldplay is French, or Beat It is not a song by Michael Jackson. So Fever was constructed based on Wikipedia. So if you're not familiar with that. So they use some crowd workers to take sentences and rephrase them as claims and then to check this against Wikipedia. So the key observation, you have a large corpus of documents where you can verify the information. So you can retrieve facts for this. So there's most probably for each of such claims, there's a sentence which can answer this claim. And this is what current NLP is mostly doing. But looking at a real life example from the fact-checking website, there is no such page in Wikipedia where you can just check it against that page and have the answer. In order to answer this question, you need to retrieve several articles from the biomedical domain, and then you need to reason over those articles, and then you need to establish the fact that this claim is false by doing that inference over multiple pieces of text taken from various sources. So that shows the gap between what we are doing in fact-checking and what the reality is. So now, debunking is complex. So how does a fact checker work? So what is their typical workflow? They have this kind of statement, hydrochloroquine cures COVID-19. And they cannot just rely on some text which can retrieve a statement and then you can match it, that is verify, and you can say, so this is not true. So the counter evidence basically for this does not exist in our corpus. So how do they still perform their task? Because they do debunk such claims. So they look, where does the statement come from? So who is the source of this claim? And they find this is this organization which is known to spread conspiracy theories. And then, yeah, they check further what the organization has on their agenda, and they have some political agenda which supports anti-vaccine movement. And then they even call those people just to get somebody on the phone to speak, and they speak to them. And then they also, of course, look at the information available in scientific repositories like Medline or similar ones. And then they can say, okay, they have debunked this claim by consulting these different sources of information and then making some, performing some reasoning over the evidence they have found and making an inference that the claim is false. So just to put it into perspective for NLP, so you have typically this architecture, you have a claim, you have a trusted knowledge base, you retrieve counter evidence for your claim, and then you can verify. So this is the Fever approach, where you retrieve a sentence, you match it, and then you can infer a verdict. Right, so the key feature here is that this is based on the assumption that you have some counter evidence for your claim. So either the evidence that confirms or the evidence that rejects the claim. However, if you have a real life claim, like the chloroquine claim, there is no counter evidence. And that makes the difference between verification and debunking. So for which we would need a completely different NLP pipeline or reasoning. And yeah, in conclusion, we find that though NLP has spent many years of research on fact checking, but unfortunately, our results indicate that we fail specifically for normal misinformation, which is the actual need of the society. So we work in some artificial scenarios. And we find that human debunking looks at the source. I showed that in the chloroquine example. It's a very important indicator for debunking the claim. So the sources provided by the claimant must be included and assessed in the debunking process. So this is taken from a special guidebook, how fact checkers should perform the fact check. And given the current data sets, this is actually, I guess, completely discarded. So the data sets are detached from this and they do not look at the source. Even worse, we use data sets like Wikipedia, which fact checkers usually do not consult to debunk the claims. And the question, how do you know that, is actually at the heart of debunking. So what we did is we manually analyzed 100 real-life misinformation claims from most common fact-checking websites, Snopes and PolitiFact. And we checked if those claims could, in theory, be handled by NLP technologies at all. And we removed the claims that were not applicable to NLP. So for example, because they were multimodal, so you need a multimodal approach, like a photograph shows a newly hatched baby dragon, so we cannot debunk this type of claim. And another type of claim is imposter, like tennis star Serena Williams posted a message on social media that, so NLP cannot check this kind of claim because it requires retrieving some other message and putting all this information together. So this left us with 75 misinformation claims that could be handled by machine learning and NLP technologies. And then we look into those basically to analyze the requirements for the NLP-based approach. So what kind of claims do we find in our data set of 75 based on the reasoning required from the fact checker to debunk those claims? So first, 20 examples refer to global counter evidence existing. So 20 examples rely on existing counter evidence. So this is applicable to NLP approaches. We do not need to know the source of the claim in that case, and we can find counter evidence via arbitrary complex reasoning only based on the claim. So this is the main NLP paradigm that we have today. So these are only 20 from these 75 and in total 100 claims. That is 20%. And some claims are very simple, but most claims require complex reasoning, including not a single piece of information, as most of the NLP data sets assume, but including finding and aggregating multiple pieces of information. So this so-called multi-hop reasoning. So an example is Ron DeSantis was never asked about the coronavirus. And if you find an interview where he is asked about that, then you can infer that this is wrong. But a more challenging claim is Kathy Manning gave nearly 1 million to liberals. Then you, in order to debunk this claim, you need to find all her donations. You need to check for each donation if it goes to liberals. And then you need to aggregate all donations and compare with 1 million. So you can imagine how complex such an NLP system needs to be in order to debunk this claim. So the second portion of those claims that we analyze is no counter evidence assertion. So it's the opposite of what NLP models assume. Not even fact checkers were able to identify any counter evidence. So for those, no counter evidence can be found. And again, in this category, the source of the claim is not needed. And the fact checkers refuted the claim by checking all credible sources to assert that no evidence points in this direction, and then they can refute the claim because they find no evidence to support it. So an example is Nancy Pelosi's son served on the Burisma board with Hunter Biden, and there is no counter evidence in any trustworthy knowledge base. And so most likely, because no counter evidence is found, then we can say that this is a false claim. So the next deals with sources, so non-credible source. So this is similar to the previous category, no evidence assertion. However, here the fact checkers know the source of the claim and what it is based up. They can refute the claim because it builds on non-credible sources. So this is quite frequent. We have 14 instances. And the example is Barcelona terrorist is a cousin with former President Barack Obama. So here there's no counter evidence that we find in the corpus. We must know the source. And we find that the source is a parody page, which is why we refute the claim. Now the next is local counter evidence. So this is the last category and it's very significant, 35 instances. So this means fact checkers were able to find counter evidence, but they relied on knowing the claim's source to do so. So here is an example. We already know chloroquine cures COVID-19. The claimant's evidence does not support the claim, so though they provide some evidence, but we find a contradiction between that evidence. And this is why we refute the claim, because the study is not a valid counter evidence. So here, an important point is that we do not debunk actually the global claim. So it's not like we find evidence that chloroquine does not help with COVID-19, but we rather debunk the claimant's reasoning. So because you cannot support this claim with the article given. So the floor is about the reasoning and not because we find some counter evidence for this claim. So only in 20 of the claims, the fact checkers could find counter evidence without the source, as currently done in NLP. And in most cases, the fact checkers needed the claim's source. This leads to the question, how realistic are fact-checking data sets if we approach the problem with a counter evidence assumption that does not actually hold? So if we want to create realistic evidence-based approaches to fact-checking, we need realistic data sets. And in this research work, we ask the question, how realistic are NLP data sets for fact-checking? So we have a good number, like 20, 30 data sets for that. So first, for a good data set, it's important that we have check-worthy and realistic claims in this data set. So I already made this comparison with the fever being the major data in the field. And looking at the example, you get free coffee for smashing shatterproof Starbucks windows. So this is not the claim, the case of a check-worthy claim, though we could check it, but it's not so important to prioritize it. So because it's not prototypical of the real life misinformation, and we want those prototypical cases actually to be in our data sets and models to learn from this. Second, we need realistic evidence. So the evidence should be unleaked. We have done another study, which I'm not presenting for lack of time, but the interesting point was that a lot of evidence in current NLP fact-checking data sets is leaked. So what does it mean? For example, it's taken from fact-checking websites. However, if a new claim appears, there is no fact check for it yet. So the data set is based on a leaked piece of evidence, which is just unrealistic because we don't have it in a real life scenario. So for example, here, piece of text from Snopes, a fact-checking website, would be taken, an image circulating online falsely promised free coffee a year to debunk this claim. However, at the time the claim appeared, the fact check did not exist. And second, the evidence needs to be sufficient if we want the evidence to actually help us However, in many data sets, the evidence that we find in the data set is actually not sufficient to reason about the claim. So for example, we can find a piece of text like an explosion damaged a sidewalk bench and shattered windows at a Starbucks. So we cannot really reason just with this information about the whole claim. And we find this a lot in the data sets. We only have partial evidence, and the evidence is insufficient to train a model. So here we have an overview of the data sets that we analyze. So these are the most popular in the arena. And the main message, without going into great detail, is that part of them contain no real world misinformation. So that means they are based on synthetic claims. But not on real life claims. And we have seen there's a vast gap between these two types of claims. And then the second part of those data sets either contain insufficient or leaked evidence, which is not representative of a real life scenario for check-worthy claims. So what does it mean? It means there exists so far, despite many years of efforts in this area, there exists no data set so far that complies with these requirements. And therefore, our current models cannot be applied in real life scenarios. So the applicability is very limited yet, and we need to drive this forward. So maybe I sound a bit negative. I have to apologize for this. Actually, so my group has contributed to this body of research. It's not like I've been born with all this wisdom. So we have produced these two data sets that are widely used in the community. And of course, they are very helpful just to make some initial steps forward, towards a solution to the problem. So I don't want to criticize all the work that has been done. It's definitely very, very valuable. The main point is just how to move forward with this in future. And if you are interested in more details about our work, we have two data sets, a richly annotated corpus for different tasks in automated fact-checking based on the Snopes data, and another one together with the Fever group on evidence-based verification for real-world information needs. And to summarize this part of my presentation, I'd like to put forward some ideas about what future NLP research should look at when we develop the methods to debunk real-world misinformation. So we should be considered with the question, what is our application scenario? So I've been talking about fact checkers. So that's one important case. So we need really to talk to those people and understand their workflows in very great detail in order to develop useful tools. I've been not talking about the general public as the target group, but this is also a very important target group. And that target group, of course, applies different heuristics as compared to fact checkers. So that's a topic for future research. So we need to include sources in the data sets, because sources, as you have seen, are really at the heart of the human fact checking. They're really important. And many of the examples in the data sets need sources in order to be debunked. And finally, we should use realistic evidence in our data sets, because many of the data sets, I have not elaborated that case study in greater detail, contain a significant number of leaked evidence. So for one of the popular data sets, as you see, it was 70% was leaked evidence. So that's completely far off from any real life scenario. And we do need evidence, and we need reasoning over multiple pieces of evidence to be able to debunk realistic claims, like the example I've given, that somebody has given nearly 1 million to liberals. All right, so now I want to briefly discuss the third and final part of our work on how to effectively communicate against misinformation. to convince, for example, people who are against vaccination to get vaccinated and potentially save human lives. So this is about how do we use automatic systems to effectively communicate against misinformation. And here we are involved in an ongoing collaboration with the psychologists and cognitive scientists in the group of Stephen Lewandowski at the University of Bristol. In this work, a taxonomy and a text data set of anti-vaxxer attitude roots were constructed, which we also performed text modeling on in order to classify the attitude root. So attitude root is a word which is not familiar to an NLP and computational linguistics audience. So what is an attitude root? So the definition comes from cognitive psychology. An attitude root are underlying fears, worldviews, identity needs that sustain and motivate specific surface opinions. So, for example, we have this statement: we can't trust information from big pharma about vaccines. So this is like something we can encounter on Twitter. And in order to rebut this information, we need to understand the attitude root, and then we need to affirm this attitude root and construct a rebuttal which uses the same attitude root. Now, what is the attitude root? In this particular example, the attitude root is distrust. And this is related to the perception of hidden motives, for example, that vaccines are only made for profit, which is quite a valid fear, right? So, and people have this fear that the big pharma companies cannot be trusted on those grounds. So the distrust can be also justified by facts. So for example, COVID-19 vaccine indeed brought a huge income, 3.5 billion in the first 3 months of 21. And so it's quite important to critically question the motives of the industry. So this fear is valid to be. And in order to respond to this and to this particular attitude root of distrust, we need to turn the attitude root against the anti-vaxxer and turn their argument on its head, so to speak. So as if many of us get COVID and suffer consequences, pharmaceutical companies would actually earn a lot more from selling the medication required for treatment of COVID. So this hidden motive of money would be even more prominent if people would get COVID-19 from the point of view of pharmaceutical companies. And so we want to identify these attitude roots automatically in order to construct effective rebuttals that can encourage people to change their point of view. So why are attitude roots so important? Because we have facts and we know how well vaccines work and why they are important. So we need to match the facts to the argument, and we also need to acknowledge people's attitudes. So just not reject them without considering what is behind them, but we want to confirm them. And to be convincing, we need to understand why people believe the full argument. What is behind that? This would allow us to form a good counter argument that addresses the specific concerns of that particular person. And in this experiment, psychologists have constructed a taxonomy of attitude roots. So these are basically these 12 labels. So we already discussed the distrust, but there are conspiracy ideation, worldview, fears and phobias, morality concerns. So these are 12 labels. They have to label attitude roots. And in this work, they have produced two textual data sets. The first data set is constructed by performing a comprehensive literature review of 20 years of psychological works on vaccine hesitancy and extracting text from the article at many different levels. And the second data set is scraped from the web by labeling fact-checking articles that rebut anti-vaxxer arguments about COVID-19. So here you can see the label distribution among these two data sets, though they are completely different in nature. But quite surprisingly, the distribution of labels is quite similar across them. So we were surprised to see this effect. So especially for distrust, fears, and phobias, and unwarranted beliefs, the label distribution is comparable and they dominate the number of instances in both data sets. So for the NLP, the interesting question is, can we use our set-fit approach that I've described in the first part of my talk in order to model attitude roots? So we experiment with this approach compared against standard transformer classifiers on the second data set of fact-checking articles, where the data is more representative of real-world misinformation. And we use a random and the majority class prediction as our baselines, along with a sentence transformer plus logistic regression classifier. And we can see that under the same experimental conditions, the set-fit method outperforms the transformer model. And then we, of course, ask the question, can we do even better? So we try to prime set-fit with expert knowledge. And the first scenario that we investigate is zero-shot classifiers fine-tuned on the first data set and then frozen. So we take the first data set, fine-tune on it, and then apply to the second without seeing any examples from the second data set, which is quite different in nature. And we can see that some knowledge transfer is possible across the data sets. But what if we perform a two-step fine-tuning, where we first fine-tune on the first data set and then continue with fine-tuning on the second data set? So, and here we indeed get much higher results, which in addition has a nice interpretation that we can prime set-fit with some expert psychological knowledge and identify attitude roots in the wild. And this graph shows that despite quite a rather nuanced annotation schemes for these 12 attitude roots, which are not easy to identify, so the coding of the data can only be performed by experts in psychology, not by lay people like crowd workers, we can see that our models can separate the roots pretty well in this 3D visualization space. So now I'm just recapping the contributions that I've presented. I've talked about detecting misinformation, where the major problem is effectiveness in a domain adaptation scenario and the efficiency of the models. Then I talked about now, of course, you can all answer the question, what is the difference between verification and debunking after you've listened to the talk. And we mainly analyzed the current research gap to propose future research directions. And the final part, it was all about how can we convince people to change their attitudes and construct effective rebuttals by using some psychological knowledge and also using the set-fit approach that we have designed. And the next step would be to construct rebuttals with the help of NLP technologies for real-world misinformation. In our ongoing work, we are building a new data set, what we call misrepresented science. So this is similar to the example with which I have opened the talk. And also we are looking at memes as a multimodal source of real-life misinformation that we want to debunk in our future work. That's all. Thanks a lot for your attention.